Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right. Well, welcome everyone. We are back after
We've
a little
had
hiatus.
a hiatus for a while. Yes.
Yeah. It's been a little hectic, just in everything.
Right.
So,
and our rules are that there are no rules.
There are no rules.
So
just have fun.
I know that they say to do a proper podcast, you should do it every single week, or else your listeners get disappointed. But
then life happens.
Yes, life does happen.
So we have an announcement about some exciting stuff coming up in Crested Butte, Colorado, where Bruce and I live.
Right.
And Bruce has done some of these developer retreats. What's a developer retreat?
Developer retreat is the lowest ceremony gathering that you can have. We get together and we do stuff.
Write some code.
And you do whatever you want.
Go on hikes.
Yeah, we usually we typically have a theme for it, but the theme isn't required. If you want to come up and work on whatever you want to work on, that's fine too.
Yeah.
It's basically I just thought of it as preschool for adult programmers.
I like it.
Something like that.
Yeah.
You know,
just
it's like
a space
it's a space, and we hang out and we do whatever we want, which often includes, outdoor activities and stuff like that. And it's surprising how much techie stuff you end up doing when you just take the pressure off.
Yeah.
That's the kind of the idea, is that there's no pressure, there's no schedule, there's nothing, but we have a good time.
Get some nerds together in a beautiful place, and cool things happen.
It's true. And the first one, which is on July 17th, which I know is coming up pretty fast, so hard to know if people will be able to manage to get up here, but there will
maybe find a place to stay.
There's some tricks there that can be had.
Yeah.
There's like camping, and I think it's now legal to camp in people's yards, and and I haven't talked to Kate yet about what's available at her place, which is a block away. Anyway, that's going to be on concurrency, which is the
first one, July 17th.
July 17th.
Is it that whole week?
Basically that week. And again, sometimes people come for shorter and longer periods and stuff. So depends on what they can fit in. And because the concurrency is the thing that I've been working on, and the subject of my next book.
Yeah.
Hopefully,
if you can figure out what concurrency is.
I can.
That's what the developer retreat can help with.
Yes, exactly. And then the second one is August 14th, and that is on the Rust language, which has gotten a lot of interest, and I've been fascinated.
Some Rust stuff. And
you've
been doing.
I've been immersed to the point where I feel like I can now look at almost any Rust example and understand the code.
Wow.
So that
says something, because I'm 10 years into Scala or something, and I still look at code I don't understand. So
I have which is one of the things that makes Rust kind of appealing to me, is that I'm able to. I mean, it does amazing things, but I'm able to understand the code. So anyway, these don't cost anything. Other than getting here.
Yeah, getting here and staying somewhere.
Figuring out where to stay. So, and if you're interested, go to the WinterTech forum. I know that's the wrong thing, but wintertechforum.com, and there's instructions about signing up for the Slack channel.
Okay.
And anyway, so once you're on the Slack channel, then you can ask questions. Yeah. It's usually just a handful of people that show up. So it's although the Rust one, looks like Barry Hawkins is coming for that, and so we have, and there were other people who expressed interest. So
cool.
So
great.
Okay,
we'd love to have anyone up here in Crested Butte.
We'll see what happens. It's a pretty interesting experience.
Great. Okay, so now on to our guest. So Mike Arnaldi, I know you from. You were doing some Scala Zio stuff, I believe. That's how we crossed paths a few times in the past, and now you've been leading this TypeScript effect system. and so kind of Zio inspired. Maybe we'll get into it in a second. But anyways, that's the backstory. So we're going to talk about functional programming effects and TypeScript and all that. But hi, Mike. Glad to have you.
Hi, thank you for having me and for inviting me. It's a pleasure to be here.
And you're coming from Italy, you said.
I'm coming from Italy, yes. I'm actually
Awesome.
currently in Italy for the summer.
Awesome. So maybe give us just a little bit of background about you and what your history is and yeah, what you're up to now.
Yeah, absolutely. I think I can do it in a way that ties into why in the hell end up building an effect system for TypeScript.
Awesome.
I've always been passionate about startups and for a good period of time about finance.
Okay.
So I found myself when I was 21 years old funding companies that tries to do highly regulated things with no budget whatsoever.
Okay.
So my kind of background is opposed to many standard backgrounds where you are in large companies and you actually have budget allocated for projects. That's to me something amazing to hear. My reality was always there's top 5 people and we have to construct a bank. We have to fight any type of regulation. And we actually have to do things right. So that kind of drives many of my decisions that I've taken lately. Now
so
that
like
startup
high
has
efficiency with low cost. Like how do you optimize that equation is like what you
how do you optimize for actually making a product and being able to transform the product over time? Because if anyone has ever built a program of any type that backs a product, a commercial product, one thing you have to account for is maintainability of the thing. You're never gonna get it right at first. We are all.
You just don't know everything until you do it, right?
First, you don't know everything until you do it. Second, you don't know what the market wants, which means even if you hit market, you're gonna have to change the thing 100 times. And there are many ways to do things. Many have chosen the path of break things and move fast. That's unfortunately not an option in many industries. You cannot break things.
Yeah, I mean, people would be a little upset if you like broke their transactions underneath their bank. You know, like that's kind of something you can't break. It's like when you have money involved.
So it's you kind of want to see how much money you have. It kind of have to be reported properly. Now it doesn't really change if it appears a second or a second later. That's also a very important part of the equation. We're not talking about high frequency domains, extremely data intensive. We're literally talking about smart scheduling of tasks, which should be a topic that's approached more in this way. You're orchestrating things, and you care that those things are done properly. You have deep care for that.
Move fast, don't break things.
Move decently fast without breaking things.
But it also has to be correct. Like
it's I like to think about it in a way that's moving fast enough without breaking anything.
Yeah.
That's
and so from that background, you discovered functional programming as a way to
from that background I found myself in a situation where we were paying like a 3,000 pounds per month of infrastructural costs to run idle programs. Those were primarily built on the JVM using various technologies. One of which was Scala, but Zio was not yet there.
Yeah.
I would have loved to use Zio for solving those problems, but wasn't simply there. And the reason it was costing a lot is because as I've been describing, those types of tasks were not really data intensive. So like those programs were idling most of the time and were top handling like 100 transactions per second. Fine, a single CPU can do that. It's not rocket science.
Not high scale.
High scale, or even it's high scale in the numbers. Like if you have one transaction for a large and you're not caring about a millisecond or two changes nothing in the equation. And for those types of problems, that anytime you touch the network, you are in that category of problems, because anything else can be only faster within that. There's like
The
speed of light is a limit. It's bounded. You as soon as you touch the network, you are in the milliseconds range. So you are in the place where kind of extreme scalability is not what you're trying to optimize for, but rather you're trying to optimize for correctness and ease of maintenance and development.
So was the infrastructure cost a factor? Because was it like a relatively high percentage of your costs were going to kind of wasted infrastructure, and so that was part of what you're trying to optimize too?
And that infrastructure was mostly a development infrastructure, so the cost would have at least doubled if it was ever hitting production. Now, that's probably, it can be optimized to much less, even using the JVM. and not arguing the type of technology, but the other element is developers are very expensive in those types of technologies, and you can find a lot of TypeScript developers. And at that point in time, Zio was coming up, and I was thinking, okay, I think I can do that in TypeScript. I was like anything in software development, at that point you are, we don't do these things because they're easy, but because we thought they were easy. That's it always starts in that way. So that's the reason why I've started building an effects system in TypeScript. I have to say it went very well, because the same developers were productive since day one, and the system ended up costing just a few $100,
Nice.
which is a big difference.
So you were doing some Scala JVM stuff, and you were kind of maybe starting to see what was happening with Zio, but then you were like, we should do the same thing but in TypeScript.
I was like, we should do it in a lightweight mode.
Okay.
And I don't like any of the technologies around JavaScript. I have to manage banking transactions. I cannot do so using JavaScript.
Yeah.
So I gotta find a compromise.
Did you look at Elm?
Yes, but one of the main purposes was using a language where it's kind of mainstream. And another important point of TypeScript is, first of all, when we look at TypeScript, we should all understand that TypeScript is JavaScript. Like you remove the types, you have valid JavaScript. It's not adding anything at runtime. It's like a smart linter with type annotations. So it's not a different language. What you emit with TypeScript, it's consumable from JavaScript. What you write in JavaScript is consumable from TypeScript. And in fact, many libraries are written in JavaScript and have separated type definitions and are perfectly usable. And that's probably an advantage, but it's not a different language. So when we talk about TypeScript now, it's very hard to discriminate between TypeScript and JavaScript, because like 90% of the tooling around JavaScript is built using TypeScript. So even the projects that don't use TypeScript directly, they're using the IDE, which is powered from TypeScript. So we are talking about probably a top 3 language, top 4. Yeah. Now I don't quite care about statistics or where things are placed, but it is a mainstream language.
So are you familiar with how Python added type annotations?
To some extent, yes. I'm not a Python expert.
Right. Well, it just sounds like TypeScript sort of did the same thing. There were the type annotations are added, but JavaScript can ignore them. Is that how it works?
No, it's kind of a static compiler.
Okay.
So you add type annotations, but the static compiler then just checks the integrity of everything. And the compilation step is removing those types annotations, emitting the same code in JavaScript. So if you have like const foo double point string equal bar, it's gonna remove the double point string. It's literally removing it as a token from the code. So
okay. I'd not
they
heard the
don't
term
have
double
any
point.
runtime. They don't have any runtime impact whatsoever.
Right. Okay.
So I'd not heard that term double point. I think it's the colon.
Yeah.
So same as
as
like Scala and Kotlin
Yeah,
use for the type and yeah.
Yeah,
so
it's actually pretty similar to the model that Python uses. The Python compiler just was modified to ignore type annotations, and then you have a separate type checker that works on it. But in your case, you remove the type annotations while checking them.
It's like reified type.
Yeah.
It's like take your whole type system and reify the whole thing or whatever. It's like,
and to be honest, it's very impressive to fit retrospectively a type system into a language that it's not native, statically typed in the first place.
Yeah.
I think the reason why TypeScript got very popular is because Microsoft is actually good at doing those types of things. The tooling is just insane, and the level to details is amazing. It started almost as a joke. Now I've been a Scala developer, a JVM developer. I've been a native developer before, so at the beginning it was hard to take TypeScript seriously. But progressively, JavaScript ended up being executed on servers. Now it's a vast ecosystem with an insanely high number of heterogeneous targets, starting from browsers, ending up with dedicated runtimes that run lambdas and half of the infrastructure of the world. Now, I'm not going to argue if that's right or wrong. That's beyond me. That's beyond me to argue, and I'm passionate about PL and different languages. So, as you might imagine, I'm not that happy that JavaScript got to win in many of those circumstances.
I don't know that anyone is.
Right. But it's the world we have.
It's the world we have. It's how we've evolved.
It's the punish we deserve, but I'm trying to make it slightly better. So that's the goal. And
so I heard an origin
language was important. Sorry, go on.
I heard the origin story of TypeScript, and I don't know if it's true or not, but I'd heard that Microsoft was beginning to build VS Code, and they were building it in JavaScript, and they got to hundreds of thousands of lines of code or something like that. The code base got large, and they kind of realized that they couldn't really make forward progress anymore because you can't refactor JavaScript like in a large code base. Like it's just not possible to do it and maintain correctness without a bunch of regressions. Like sure, you can say like maybe tests can fix that. Who actually has enough tests to like catch every little possible thing that you in a refactoring could screw up?
Is even an advantage having like I've seen a lot of library code bases and I've seen a lot of app code bases. Having 100% coverage unit tests on an app code base, I don't know how smart it is. I've never got much out of it.
Just a waste of time, yeah.
It's probably just a waste of time. Now I respect people who want to waste their time. I'm not here to judge other technologies, but I'm not gonna do it myself. So I want instantaneous feedback within the IDE. That's actually one of the things that TypeScript gets you, and it gives you pretty decent error messages. Now they can be better, sure. Everything
so getting like error messages, like good IDE code hinting, like all that stuff requires types. And so back to the origin story, I'd heard that Microsoft, when they were doing VS Code, all in JavaScript, they got to the point where they couldn't make forward progress well. And so then they're like, we need to come up with a language on top of JavaScript that gives us types so that we can then move forward.
Plus, they had
quickly.
the example of like CoffeeScript, which helped.
Yeah, there was some inspiration for
so
for
it's possible to lay
JavaScript.
something over it and make it better.
Yeah.
And so
there is a flaw in JavaScript being a bad language, that we tried from the very beginning to compile other languages to it because it was too painful to write directly. So that the tool chain of building and transforming JavaScript is actually very old now. So they didn't get a lot of friction because they introduced elements of compilation to the toolchain. The community was fine with that. It was the period where ECMAScript 6 was coming up. People wanted to write ECMAScript 6, but they couldn't because the browsers were compatible with ECMAScript 5.
Right. So they were already transpiling.
So if
you're going to have to do some transpile, why not add some type annotations in there and get all these benefits?
So was it Anders Heilsberg who started?
Yeah.
Okay, that's what I thought.
Yeah, that's the same.
He's quite
the
a good language
person
designer.
that is behind C#.
.NET, yeah.
So which is a good driver of inspiration for TypeScript.
Oh yeah, he's a very smart guy.
So of course, anyone that was kind of in this realm of JavaScript was like, and maybe not anyone, most people that had a large code base in JavaScript were like, of course this makes sense to like have a type language on top of JavaScript, get all the benefits of that for refactoring, for code editing, compiler error messages, correctness, all that kind of stuff. So it all makes sense how this evolved, and now I think anyone that's going to want to target JavaScript, like TypeScript, is probably almost the default at this point for what you would do.
Weirdly enough, I was teaching the very basics to a friend. And I was like, okay, let's open an IDE. Let's start learning the very basics of JavaScript. And I was like, oh gosh, I don't even remember like a very basic method name or stuff like that. I was like, no, okay, that's actually not the right way to learn, because you're not gonna learn. That's how you learn languages, like I learned languages. But I was studying languages on piece of papers, and I was studying C specifications, and everything moved very slowly. We didn't have extremely large code bases. Processes were different. Like now you have an IDE that tells you all the methods and everything else with just a few type annotations, and types are one of the most important concepts, because whenever you represent a real life problem, you have a domain that you should. It's almost like a language within a language. You should write code that reads similarly to what you would actually
your business
to how you would explain the same problem to a person. Otherwise, there's a disconnect. Like the reader of code is a person. Then it instructs a machine, but the instruction of the machine is a translated element. Like the only one who actually reads the code directly and has to reason about it without help is the human.
Yeah.
That's a very important.
And the types are very helpful at
the types are very helpful to get that part, like seeing a variable which is called a user, or not knowing what a user is, not knowing if the user has a field called name, or like it becomes very messy very quickly.
So the types should serve the developer. They're not there to serve the machine. Like the machine doesn't care about the types, but the developer needs the
Zio got it actually right, because it's very easy for you to manage the types of an app, and you gotta know the basics. Like, okay, to write extensions to Zio, you have to know proper Scala, but to use it, you have to write a case class with basic implementation, call a few methods.
Yeah.
And you get all the benefits of FP. But for example, my goal with Effect was not to make FP popular, was to actually build apps. And that was the way of have the code maintainable and have the code efficient enough that could run and have a hiring pool of half the work.
So you were seeing the Zio stuff happening, and then you're like, hey, I want to go TypeScript, but I want to have some of those same benefits for the stuff that you're building in TypeScript that Zio has. And so, tell us more about that journey.
Then I hack a module, like everybody does. It starts in AppCode. Starts pretty small with the basics ideas. But the first question was, can I even represent the whole context, environment, parameter, the whole error, the variance of it, how it mixes, and those elements. So it took a while, but was not the hardest part. And I've realized from the very beginning that TypeScript is actually quite flexible. And given it has a very flexible type arithmetic, and it includes intersections and unions, like, to me, the most natural things at the beginning was to represent services through an intersection type, and the error channel through union types. That ended up being the solution for Scala 3, because that's how the variance ends up mixing. So type signature looks a little bit different, but then...
But wait, you said intersection type. Is that a sum type? Is that what you mean by that?
That's the end type. So it's like A with B with C with D with A. It's a type that is both.
Yeah, so there's different ways, I think, and subtle differences between them, between like algebraic data types, the sum types and product types, and the intersection.
Product type is distinct. So the intersection type it's not distinct. It's like the same value that has multiple interfaces on it. You could see
sort of like way. A union.
The union would be the value being one of the interfaces, being either one of those. An intersection is being all of those.
Yeah.
And
so your services are intersections because you can have a service that needs a database connector or whatever.
You can have a program that to run, it requires a database, and it requires a connection pool, and it requires a user service, and it requires a cache. So it requires all of those to be given in order to run. Now that's how it ended up being in Scala.
With the environment
with the environment type.
Zio.
Yeah, with the environment part of Zio that ended up removing the need for has. Because you remember in like 1.0 it was has 0, has 1, has 2. A bit more complex. Now it's a fake type. It does not map to anything. It's called a phantom type. Now in TypeScript, that's one of the things that works slightly differently. Why? Because TypeScript is structural. So if you have two types that are equal, that look equal, they are the same type for TypeScript. So an intersection type, if you have one type that has a field that collides with another type, the full thing is going to be never, because the TypeScript is smart enough to say, look, that can never exist. You can never have a value that has a first name which is both a number and a string. There is no value that is both a number and a string, so my whole thing is never. Which doesn't work that good. It's fine doing it with a union type. So for TypeScript, we actually use a union type for both. So there are minor differences, but conceptually, you're trying to represent the same things.
Yeah.
And TypeScript is powerful enough to do it, which was surprising to me at first. And the journey of adaptation didn't take a day. We went through
iterations,
learnings and failures and failures and failures, like every technology.
So you were trying to take
the point
kind of
the pretty good.
Yeah, you were trying to take the kind of concepts of Scala and Zio and map them to TypeScript, and then there were some changes that you had to make to kind
of fit. And
then
it's like, what should you leverage from the language to make it better, and what trade-offs you have to make, because you cannot represent some things. It's true in the opposite side too. For example, in Zio 1, there was no way of providing a single context parameter to erase partially a type without specifying the residual manually.
Yeah,
we could do that from day one.
Nice.
For TypeScript, it was absolutely no problem. So there are things that you can leverage in the language that makes it nice, and there are things that you have to compromise. Like I would love to have some implicits in TypeScript, but or context functions that I know in Kotlin and other languages are getting. Unluckily enough, I know that that's never going to happen.
Interesting. So what about the runtime side? So I think some of the magic of Zio kind of happens in the taking a definition of an effect and then the runtime then figuring out how to efficiently take that definition and run it and map it to actual threads and all that. Like, was there challenges in coming up with kind of the effect runtime piece in TypeScript?
Surprisingly enough, it's very similar. Now, even in Zio, we went through iterations of what the runtime means. Funnily enough, when converting the runtime to TypeScript, I found bugs on the original runtime in Scala, and I've backported the fixes.
Yeah.
Simply because they were so similar in principle and in concept that, okay, if you see one-to-one, this does not compile in TypeScript. Why does it not compile in TypeScript? Oh, there's an error in Scala. Or, oh, I'm doing something different in TypeScript and maybe I got something wrong. Now, it happened both ways. So the runtimes are very similar. The only difference is we don't have to care about the problem of allocating multiple threads. We don't manage a thread pool. We have one thread. We have to intertwine the effects on the same thread. Which, from a high performance point of view, might not be the best. But again, with TypeScript, we are managing the orchestration code. So orchestrating tasks. Even when it's on the backend, nobody's going to do the data element in TypeScript. They're going to call APIs, they're going to call databases, the whole thing. And one of the misconceptions is actually that Node is in full single thread. No, you have one thread for coordination, but if you schedule an HTTP request, that's going to happen on a different thread. You're not going to block the thing. So it's like one coordinator, which JavaScript is very good at executing IO tasks. Something like Zio is very good at describing those IO tasks. One plus the other makes a lot of sense in my view.
Yeah. So, maybe we should take a little tangent to effect systems. And it sounds like you kind of discovered effect systems. What was the value that you saw in effect systems?
Again, I actually had to test the code and I had to make the code reliable. So to me, being able to express like an exponential retry policy in 2 lines of code was mind-blowing.
Yeah.
The reason I've understood that it was mind-blowing is because I had to write it normally, spending hundreds of lines of code, test it, debug it, and don't even know if it works, and having pain in changing things. Testability is another aspect. Now, folks like to do testability via mocking. I hate doing mocking.
Yep.
I love test containers running real databases in test environments. I know you love it too.
Yeah,
because
love test
I've seen
containers. For
some
service dependencies, it's the best there
Yeah,
is.
well, I like to have a layer in my tests. I have a layer that creates the infrastructure through test containers, extracts the network configuration, the database configuration, anything else, configures my local services, provides the local services with the database connectivity, runs the real API. I have a thing that fires across the real API. I'm testing the live thing. Do that without effect systems. Have fun. Literally, have fun. I realized from the very beginning that the level of abstraction you can represent through effect systems and the level of modularity and composability that you get over time, it's gonna win. Because the only thing that takes you is building the right primitives once. Yes, takes a lot to do a proper database client. Figuring out database pooling, everything else takes a while. Once you've done it, you don't recreate it twice. You just use it within your code and it just works. you change it to a different database, it's literally differences. In TypeScript, we got to the point where we have RPC systems. The next stage will be developing sagas and distributed workflows. That's another thing we've been chatting on Twitter about, but the full idea is, yes, we are orchestrating tasks. We have to smartly define those tasks. Not all the tasks have the same requirements. For example, if you have to call 3 APIs in sequence, you probably don't need any general purpose programming stuff. You just need something like a zero flow, which you can just post a transaction from a lambda to an executor, and the executor takes care of actually doing that for you. So you're shipping a task to a different place. You're moving the computation, not only there's moving data or moving computation to. So we want to bring composability to the full infrastructure, and I think literally effect systems are the right primitive, because otherwise, how are you gonna compose all of those solutions in a way that you can actually use those?
Yeah. It's like we I think figured out, functional programming is really great for composability, and then effects are really great for composability of effectful stuff. And I've never seen a better model than effects for managing composability with effects, things with side effects. But then I think what you're saying is that kind of the next level of this is distributed systems are the like last frontier where composability has been absolutely terrible. And how do we bring a better composability model to that level, to the distributed
and for us,
side?
It's kind of a necessity, because now I'm gonna say a thing that when I say this, usually people look at me in a very weird way. Your browser is a distributed system. Your browser. Why? Why in the hell is it a distributed system? It runs on my machine. Well, it runs on your machine, but a single JavaScript engine can have workers. They communicate via messages. They can fail. That's the same. They don't share memory. You can't pass an object between the two. You're literally like doing HTTP calls within your browser with the same network failure scenarios. You just have different latency.
Yeah.
But you're doing distributed systems and you're programming inside a browser. You add WebAssembly, you add other pieces of the equation, it's messy. It's gonna get messy very, very quickly. And
So
I think
how much of your effect project is kind of targeting browser applications versus server-side applications? I think it doesn't matter to you whether people are using this on the server or on the browser, but is there more usage in the browser side, more usage in the server side? Like, what do you see?
Community-wise, I think we are 50-50.
Okay, interesting.
I can say that the reason I've built Effect in the first place were more tied to backend. I was planning to use TypeScript to orchestrate distributed workflows, such as, for example, clearing of transactions and things like that. So processes that could take weeks, that may require manual intervention, not manual intervention, be partially automated, they have to be auditable, they are highly regulated, and so on and so forth. So that was my realm. But the system ended up being very small. And turns out that, again, I've realized even the browser shares many of the problems of the server. And at this point, I believe we have a 50-50 of people. Some of them are thinking, how would a rendering stack look like if built within Effect? Now, that's something that would
please do something like the Elm architecture on top of Effect.
There are folks that are doing that locally. I am not a front end myself, but as soon as I get the right idea, I'm thinking the point is, it's so vast. The problem of answering this question is that it's so vast that if we get the right idea about a front-end usage, we have a small enough runtime that's perfect for usage in all of those. The runtime is like compressed 10 kilobytes.
10 kilobytes. Nice.
Compressed.
So, yeah.
Right?
So
it's
totally viable for
totally viable for any type of usage. Of course, if you then use, like a friend of mine recently had a local first app, which is actually Johannes Schiefling, which is a team member of now of Effectful, which is the company behind Effect. He has a local first app where he runs an SQLite in browser. He writes queries and everything to the local SQLite, and that gets replicated across the network. So it's a slightly different type of architecture, and he's using Effect for a lot of his code. And we were checking his bundle, and I was like, dear friend, do you realize you are using 150K of Effect library code? Like, I don't even imagine how big this app would be without those 150K of code.
Yeah.
So you start with 15K as a minimum, but you have so many things that I guess the same app would be at minimum 3-4 megabytes if not using those highly composable blocks.
Right.
It's like when I check,
just be a lot of duplication, a lot of stuff to manage subtle differences.
Yes, and even a basic thing like streaming, it's pretty efficient, the actual implementation of a channel fiber or of a channel in our terms. They're not too big, and they give vast benefit. Now, initially, again, I've dismissed usage in the front end for a while. I was disadvising usage, but actually front-end friends told me, no, you should not disadvise usage because we're using it against your advice since a year and a half, and it's going as smoothly as possible, and it's actually great. So,
well, the abilities there, I don't know if there's a good word for them yet, but like the capabilities that you can add onto anything through an effect system, I think would have so much value too in the front end. So you need to retry something, dot retry. You need to put a timeout on something, dot timeout. Like the universality of those capabilities, being able to apply them at any level of your program, I think
and
has
there
so
are
much value
things
for
that you
front
do,
end as
like
well.
recently, for long I've been investigating and quite passionate about the Zio Query project, which is to do batching and caching and optimization of data fetching in Scala. At some point in time, I was like, maybe I can implement this directly inside the fiber, making the equivalent of any Zio, or in our terms of any effect, cacheable, batchable, and so on and so forth. So now, actually, in effect, you, without any change in code, you can declare an effect to be a request, and that request can be batched, cached behind the scenes without any change to your code. Those capabilities, without a pure description of a program that only later gets interpreted into a running program, into an execution. If you don't have the description, there's no way you're gonna do this type of abilities. That I think it's the same concept as you were referring to. That's like, there's no other way of just having a program and say, please retry 100 times if you don't have the description to begin with.
That's
well,
right.
The same concept goes around batching, goes around caching. My bet is that we'll go around persistence, we'll go around network interactivity, we'll go around executing distributed transactions, and will progressively pay off building abstractions that compose between themselves, and building the
what's
right
required
blocks.
What's required at the foundation of that is the effect system, because that gives you the ability to manage resources.
You have to have universal composition as a guarantee. Otherwise, you're gonna screw up.
And
if
the
you
effect
don't have
is the way to encapsulate that.
If you don't have a single way of encapsulating that, it's just a matter of time. You're going to build two things that don't talk to each other well. Have a single base.
So would you say that composability is maybe the whole reason for functional programming?
I think the whole reason of functional programming has always been very clear since the start. And it's the ability of reason equationally on for your program. That means you read the program and you can do the same operations as you would do in a normal. You can transform it mentally. You can just, if you take an equation and you slice a piece and you move the piece on the next line, the equation does not change in any way. The code has to have the same property. I think that's what the objective of functional programming has always been. But then I believe for ages we've confused the how with the what we were trying to do. So we are trying to write software that we can all understand, and we are trying to write software that's not too complex to maintain, because we all love software, we all love to build products, and we all love to concentrate on what the customer wants, not how should I call a database. Why do we even need to write Postgres connection strings manually, or what have we been doing during the last 40 years that we still have to write how to do things instead of what we should do. So I think the programmer wants to write the what they should do, and what we've confused.
We get stuck in plumbing, managing resources, handling errors, or ignoring them.
That's from the industry perspective. From the research perspective, is like, yes, math and monads are a nice way to represent sequential computation. Fine, nice, mathematical result. I'm a mathematician myself. I love theoretical results. But actually, that's one way. And yes, a monad is a very smart thing, but composition of monads is not a given from the mathematical theory. There's different ways to go about composing things, and what we should focus is how do we do it best within the language. So I don't like when somebody say type classes are the absolute best because they are the absolute best in Haskell. Sure, if I'm writing Haskell. Implicits are the very best in Scala. Maybe no. Type classes are the best in TypeScript. Absolutely not. There are clear differences, and I think even like the godfather of Haskell is now exploring other ways. There's other functional languages coming up that approach it differently. Like there's research from Epic Games. I would like to see the primary objective being write programs easily, and composition is just a very good thing that comes for free if you do things right. If you don't actually do things wrong on purpose and write zero programs or effect programs, they are gonna compose. Yes, and doing something that makes them non-composable, it's fairly hard. You have to be smart to do things that don't compose in zero or effect. I can guarantee you there are many. I can guarantee you that every language in this world is unsound to an extent, including the very best Zio app or effect app, or the very best compiler. Everything is to a level screwed up. But
we do our best to try to make sure that the happy path is composable.
Yeah, make sure that the happy path is composable, and let the user be very aware that the unhappy path exists and how to deal with the unhappy path. It's like I want to write my computation, but then like one of the principles that really that I loved about Zio from day one was Zio has three parameters. They represent three things. those three things are the output of your program, they are the possible error cases that your program may encounter, and they are the dependencies that your program requires for its execution. Now, I would argue that every piece of code in this world has these three properties. Maybe some of them are never, none, any, or they are degenerate cases. But if I have a program that tells me this is an effect that doesn't require any context, that can never fail for any predictable reason, and that gives me a number, I know I have nothing to manage in the unhappy path. Now, it does not mean it cannot succeed, it cannot fail. It can fail if it blows up, but like, I don't want to recover a disk failure. I want the program to crash, tell me that the disk has failed, and be over. I want to recover from the case where I had a network failure that is completely predictable and it's fine to retry exponentially within 5 seconds. If after a minute it's done, yeah, I want to die again in zero terms and let it escalate. Like, those types have a meaning about every piece of code, at least every piece of code in opcode that I have ever seen.
So this is back
Making
to the conversation
that concept
that
clear was an absolute game changer in my view.
So Bruce and I were talking about actors recently, and Bruce was asking me what I don't like about actors. And one of the things that I kept coming back to was that actors are not explicit about exactly those three things. They're not explicit about the required dependencies, the possible failures, or even the output. And I love one of the reasons why I've loved Zio is that you have to be explicit about all three of those things. They're in the type definition. And so that explicitness helps you be more correct and more composable, because you've had to explicitly state those things. Whereas in the world of actors, there is
not really even on the menu. I mean, that's just we don't think about those things.
Yeah. But certainly when you send a message to an actor, certainly there are dependencies. There are ways that it can fail. There are outputs. Like, all that still is there, as Mike is saying, but it's not explicit. You just fire the message and don't care
what
something
happens.
Yeah, it's very
And so the explicitness is I think what really I was like, oh yes, this explicitness allows me to be correct and composable in an expectable way.
And I mean, one can go two ways about the explicitness. There's folks who likes the explicitness because they say, okay, then my program does exactly what I want it to do. And then there are people like me that almost say we don't really care if the program does the things perfectly. What we care is that it is very hard to break. And if I forget something, I have a red squiggle in my IDE in 0.02 milliseconds within the feedback of and this is where I believe that really TypeScript wins over anything. Like, it's just there. It's a friend that you have while you program that tells
you've been explicit. You've done the work to be explicit, and then
I'm telling you, I want to manage the error. Tell me what errors I have to manage. I want to manage the error number one. Okay, the error number one is this error. If you handle it, only that error is removed from the list of errors. Like, we have functions like a partial catch that just extract a single error from a computation. So you can say, okay, like I have this program which can fail for a network error, can fail for a database error, can fail for a user domain error. I want to retry on the network error, just the network error, ignore the rest, and the result no longer contains a network error. It still contains the other two, though. So it's like, that's a friend helping you. That's not typing going in your way. You can, like, this leads in more broader to the two school of thoughts. Should I declare all the types? Should I infer all the types? Like, I'm I'm not gonna suggest strongly anything, but I've seen inferring first to work extremely well, and just annotate when you actually know what you've done. Like you write an effect, or you write a Z, or you write. I believe this concept will spread to other languages. I hope at least. You infer the whole thing, and then you see, oh, I have used a database connection. This program may fail for A or B, and it's like, okay, key binding in VS Code writes the type automatically, and I go on. Like that's using the compiler as a friend, not as an enemy that later on checks what you wrote and shoots you in the face. No, you're wrong. Like, why haven't you told me what I was typing this that I'm wrong?
Right.
That's where I see the huge advantage on this lightweight toolchain.
Yeah. So, quite a tangent. You mentioned monads, and I've assumed that Effect uses the same kind of monadic model as Zio. Is that true?
Yeah, it is a boxed representation of an I/O computation.
And then one of the complaints I hear people making about things like Zio and other functional programming systems is that monads are hard to learn. In the world of TypeScript, has it been challenging to get JavaScript, TypeScript developers to understand monads and flat maps and whatever,
Thanks for
all the monad stuff?
Thanks for this tangent, because it's a tangent I forgot about, but it's a tangent I'm extremely excited about too.
Okay.
And funnily enough, it's one of those cases where we can say we were there first. And I think monads per se, we don't have to talk about monads in a classical sense in any way. Do you know async await? Yes. Yep. If you know async await, that's it. That's as much as you should know to use.
So you're not exposing like the flat map change.
We are.
You have something like the do notation or the for comprehension at Scala.
We actually have the generator notation, which has the same exact power as async await, which means you can even do while and await on the condition itself, changing the variable at every time. You can yield effects, and it's gonna track automatically the error type and the environment type, and it's gonna build it. It's gonna build your. Now it's a little verbose, and I would like to get that at some point to a more custom DSL or whatever else. But literally, if you set up two VS Code snippets, I type GG to write the generator and YY to write yield, which is the equivalent of await in the generator terms. And you can program just like you program with promises, just like you program with anything else. Like call the database, then do that, then if this, then switch over. Like have fun in doing imperative stuff. Now, of course, we have functions exposed, and there's only going to be a subset of things you can do inside a purely procedural thing, because functions are more higher order. But for the basic stuff, you can do it normally. And then I don't think anyone is scared about saying effect.retry and retry 5 times and then pass the other effect. As long as I can write my core logic without thinking about flat map at all, I think that's the win, and that's what we are seeing other languages transition over. So I'm excited for Scala. I'm excited for Kotlin, because I think when you program, it's like that.
We've been using Zio, writing a book about effect stuff. Bruce and I and our friend Bill, and we started with just regular Zio, and then maybe a couple months ago we're like, Zio Direct looks really interesting, because for the audience of our book, we're assuming that they maybe don't want to learn monads and do everything through flat maps and all that. And so we started using Zio Direct, which gives you that direct procedural look to Zio code, and we started migrating our code over to Zio Direct, and we're like, we just were like waiting to see when are we going to reach the place where we're like, okay, this falls apart. This is a bad idea. When are we going to hit the wall? And we have yet to like hit the wall. And I think at this point we've converted almost all the book code over and all our like experiments over.
We're just like 3 years in. You're not gonna.
So that's great to hear that you like went on this journey before us, and now you're in that place where you're like, great, like if it's great that monads are underneath the covers. It's great that we have that foundation. It's great that flat maps and the functors and all that kind of stuff is there. But for a lot of uses, maybe we don't have to expose people to that level.
And like people almost fixate on monad being an extremely important thing. Yes, it is, theoretically. Practically, it describes 3 functions. In Zio, there are like 1,000.
Yeah.
Okay, if you talk about monads, you're really talking about 3 of those functions. It's a composition of those 3 of those functions.
Yeah.
Fine, good. Sort of stops there. For me, the most interesting stuff is, okay, can I write a program that I can actually read? Because it's funny, when I ask FP developers about how they like to write code, then they start, okay, the structure, the data structures involved, the type classes, like the modular infrastructure, I'm going to shift that, it's going to call the database in this way. And I'm like, okay, would you explain to me, please, how does Facebook handle a message? And they say, okay, then it does an API call, then it does a database write, then it does this other thing. Like, do you realize that you've described it in an imperative way?
Yeah.
Why in the hell would you want to write in a different way?
Yeah.
It's how you think. Why? Now, this may be a Stockholm syndrome induced by 50 years of program. I don't know if this is the pure way of doing things. I don't care if this is the pure way. It's the way I think about things. So I would like to see the same in code. Okay, do this, do that. Then if this is like this, do this. Or please switch over the cases. I would love to have pattern matching. We have similar approximations of it. Kind of make some trade-offs, but you write code that you can actually read. And
yeah. Well, and the ability to deal with domain-oriented things like just putting .retry on something. Sure, you could instead do a flat map and do something as a flat map.
Recursively. Just put a retry there.
But it's so much more domain-oriented to just say .retry. It reads to what the problem that you're trying to solve. And yeah, retry is built on flat map. And it's great that flat map exists underneath the covers and provides a foundation for all this. But yeah, for most people, they're writing code that is at the domain business problem level. And so they just want those higher level abstractions. And yeah, shouldn't need to think about monads.
I like the way Rust has done it, because if you're looking, you can go, oh, they're using monads here and they have support for it and everything, but nobody ever uses the word in the Rust community.
Yeah.
I'm not
the functional programming community, I think, it went through this process of like discovering monads and realizing how amazing they are. It's like, I got to tell you how amazing monads
are. What monads are,
because they're so amazing.
Yeah.
And it turns out maybe, yes, they are amazing, but does everyone really need to understand them?
Yeah, and then there are things like applicatives and other type classes that honestly, I love the categorical representation for mathematical things, but an applicative categorically does not make sense. It makes sense in the functorial way, but it's rather a monoidal thing. It's a thing that makes products. It's not a thing that applies to another function. That's because Haskell is curried. That's a way of applying embellished values to an embellished function in Haskell. Like has nothing to do with the pureness of the mathematical representation, or it's just a hack for the language you were in. We are doing the same hacks in TypeScript. Folks like John and their teams have been doing the same hacks to make it work in Scala. I believe the folks behind the FP libraries in Kotlin are making the same types of trade-offs.
Yeah.
Like, we are all trying to adapt in the language, even when we speak. Like, sometimes people tell me the perfect language to do philosophy is German. There's a perfect language to express some topics, but we all manage to communicate. Means we are sort of adapting concepts to as best as we can to the language we are in. That's the same thing we have to do with programming languages. They shouldn't really be any different from human languages.
Yep. All right. Well, Mike, that was super fun, and appreciate all your insights on that and all your work on Effect. It's great to have these concepts able to be accessible by a whole nother set of developers, because I think, like you, I believe that effects are a great way to help developers be more productive, create better, more reliable programs, and all that. And so glad to see that out there, and great thing for whole nother millions of developers to be able to hopefully move forward with.
Again, thank you for having me. It's been a pleasure.